Hello everyone, good day. It's a pleasure for me to speak on this special online event. And I'm happy to present some work we've done on the concept of Synbiotics in early life. And I would really like to talk about the inspiration we got from human milk and how these Synbiotics can affect the gut microbiome in infants that particularly need support on the microbiome development. Just to start with, my disclosure, to be clear, transparent, I'm a full-time employee of Danone Nutrition Research in the Netherlands. And besides that, I'm also part-time professor in microbiology, gut microbiology at Wageningen University in the Netherlands. So early life is really a critical time for development of the infant, as you all know. The infant is not mature, many of the organ systems are not mature, and steps still have to be taken after delivery into this world to grow the body, to grow the whole biology of the system. And we know that specifically also the gut has to mature, the microbiome has to establish, because infants are born more or less sterile without microbes. And they have to colonize the guts and form the gut microbiome. But also the immune system is rather naive when we are born. So the immune system also still has to learn what are good signals from the environment, what are danger signals. And these processes go pretty much hand in hand. So the development of the immune system in early life is triggered, of course, by the food we eat, the milk the babies drink, and this then triggers, of course, the maturation of the whole gut system. The microbes entering the system, the maturation of the immune system should then lead to a stable homeostasis that supports our health throughout life. But of course, also things can go wrong in early life, and this is what we see more and more, and we see the rise in infections and allergies in early life, food allergies, but also asthma, and also immune disorders or non-communicable diseases in later life. So it's really important to understand this early phase in life and how we can support the optimal development of the system. And it's quite clear for all of us, I think, that a healthy gut microbiota is important for the development of the immune system because they react so much to each other. A large part of our immune system is in the gut, and in the gut is also where all these microbes in high numbers are becoming very active. So to regulate the microbiome composition, the immune system plays a role. But of course, microbial signatures also have a huge impact on immune responses on the host site. So the early exposure is important to both develop the gut microbiome as well as the immune system. And there's lots of interactions going on in this very interesting organ. Of course, the gut is responsible for digesting our food, taking up essential nutrients and energy. But it's a rather complex system where the mucosal immune system really plays a very important role in maintaining immune homeostasis, suppressing responses to harmless antigens, including beneficial bacteria, but also responding to threats like toxins or pathogenic bacteria. And we know that if the process is not going very well, we get a disbalance, also referred to as a dysbiosis in the microbiome. And this can trigger several immune disorders through also activity of T cells. And the most important ones are, of course, allergic reactions, but also, on the other hand, infections. And we know now very well that the microbiome, once it's developing and established, that this gut microbiome actually is a very important barrier against pathogens. So a healthy and balanced gut microbiome acts against infiltration of less desired microbes, pathogens, and therefore preventing also infections that these pathogens can cause at the epithelial layer. And there's many mechanisms behind this. Of course, it's a very crowded space where microbes compete heavily. And of course, the good bacteria can in this way compete with the pathogens for adhesion sites and nutrients, for example, which leads to production of acids, weak acids, that again are also very much inhibitory to all kinds of pathogens. So an acidic environment is created where specifically saccharolytic bacteria thrive. The well-known bifidobacteria, lactobacilli, they love these conditions, but pathogens cannot colonize these systems. Of course, the bacteria also support the epithelial health, including tight junctions, but also mucus production. So by supporting this barrier integrity on the host side, beneficial bacteria can also make us resistant against the more pathogenic bacteria. But in modern life, there's also quite a few threats to the developing microbiome. There's quite a few things that we put on the developing system these days that can cause disturbances or dysbiosis. Practices have changed, sometimes also, of course, for very good reasons, like the use of antibiotics. It has saved many lives and solved many infections. But you can imagine that early life antibiotics have a huge impact on the developing microbiome. Duration of gestation is important. So preterm infants, they have also an aberrant microbiome development, and preterms is also on the rise. Of course, C-section, very important example, I think, because infants that are born in a sterile operating theater have a very different exposure to the microbial world after they are born than, of course, naturally delivered infants. And we see that this has also a big impact on the developing microbiome. Hygiene has changed, diets has changed. So in the last, let's say, 100 years or a bit more, of course, this is big impacts on the developing microbiome. But if the microbiome develops well, we go into a healthy system, a homeostatic system, which is important for immune tolerance, for gastrointestinal homeostasis, but also for healthy metabolism. And nowadays we also realize the important link of the gut to the brain, that this can even impact also brain health. But if the microbiome is disturbed significantly in early life, we can also have dysbiosis, which is quite often associated with immune diseases like allergy, asthma, gastrointestinal diseases, but also metabolic diseases. So it's really important to understand how this development is influenced by factors like diet. And this is, of course, an advantage that with nutrition we can directly target the lumen of the gut and influence also the microbiology of the gut. And this is also what we see in cow's milk allergic infants. They often have an altered gut microbiome compared to healthy non-allergic breastfed infants. So healthy infants have dominant levels of bifidobacteria. We also see E. coli, Faecalibacterium prasunici as a butyrate producer is important to also establish in early life. And we see many different lactobacillus species to be there from an early stage in healthy breastfed infants. But in allergic infants, we quite often see that these numbers are lower and that we see more prevalence of enterococci, methanobrevi, clostridia type of bacteria. So we seem to have this dysbiotic state in cow's milk allergic infants specifically. And of course, we have solutions also as nutritional solutions for allergic infants. Many formulas, of course, are there to support these infants high risk of allergy or already suffering severe allergies. But of course, these formulas do not always contain the right support for the microbiome. Whereas human milk contains even live bacteria, we now know. Human milk also contains a lot of substrates for beneficial bacteria. So human milk is actually really driving also the development of the microbiome. Human milk is not just feeding the infant calories and building blocks, but human milk is also actually feeding the microbiome. And in traditional formulas, of course, this was lacking. These formulas usually did not contain live bacteria or prebiotics, human milk oligosaccharides to support the growth of beneficial bacteria. So this is where this concept comes into play, the symbiotic concept. We think best of both worlds. Just for the people that don't know, Synbiotics is a combination of prebiotics, so the substrates for beneficial bacteria to let them grow and be active in the gut, plus probiotics, which is actually feeding individuals or babies with live bacteria. And if you give them at high numbers, we can impact the gut microbiome, and we can actually also confer health benefits to the host, to the infants, with these concepts. Well, we have a lot of data, of course, behind this mixture. As many of you may know, we have a lot of data on the prebiotics, the GOS and FOS mixtures, which actually mimic the level of substrate in human milk, but also functionality. They're of course not the same molecules, but they very much have the same functionality. And we have studied this in more than 30 clinical studies. And there's also now recommendations for these prebiotics, or at least acknowledgements for the benefits of these prebiotics. Then we have also in this concept a probiotic, for which we have selected a very specific Bifidobacterium breve, the so-called M16V strain, because bifidobacteria are in human milk. They're in the gut of healthy breastfed infants, and this specific strain is selected because it's able to reduce allergic responses, at least as shown in preclinical, but now also in clinical studies. So this is very strain specific for this specific probiotic. And together, by influencing the microbiome, the activity of the microbiome, but also providing specific live bacteria, we can synergistically target the gut microbiome in dysbiosis. So we have a lot of evidence, data, of course, from human milk. We still learn every day from the composition of human milk, a very intriguing liquid. And in human milk, of course, we have very large amounts of very different human milk oligosaccharides. And these have different functions, but an important one is also, of course, to act as a substrate for the growth of bacteria in the GI tract of babies. And now we have mimicked more or less this complexity of molecules in size, with very different sizes, with also the development of specific prebiotic mixtures, where we have the same size distribution, a lot of diversity in molecules, and also these substrates, specifically the galacto and fructo oligosaccharides, are good substrates for beneficial bacteria in the GI tract. A few more words on the probiotic, the M16V. I truly believe it's a unique infant strain. Bifido breve is really the most commonly isolated species from human breast milk. It's in the gut of healthy breastfed infants. It's a typical infant human type of bifidobacterium, in contrary to some of the other species like Animalis or Lactis. The strain is therefore also resistant to certain antimicrobial activities in human milk, showing indeed that this strain is also present when infants are human milk fed. Very adapted to this niche, and I think it's really an example of co-evolution between us humans and bacteria, where this collaboration is also supported by, for example, human milk. We have a lot of safety data also on this probiotic strain, specifically in sensitive populations like infants. It was also very much selected because of this strain's data we have on safety. For example, this strain has no undesired antibiotic resistances, which is quite a big topic in using live bacteria these days. And we also have a lot of in vitro and also animal models, data from that, to ensure that breve is colonizing, is efficient, but it's also free from any major allergens in the production of this probiotic, which is also quite unique. Well, we have studied this concept of synbiotics already for many, many years, and we also have a lot of clinical data to support the safety, the efficiency, the equivalent, or the suitability, let's say, of this concept in this target group. So we have scientific data from our preclinical work. We have mechanistic data also on immune models published already more than 10 years ago. In the study of Harvey, we've also shown that this concept is safe in healthy infants, and that it's hypoallergenic according to the AAP guidelines. And then in further studies published by Burks and Candy, we also have seen that this concept is safe, well tolerated in infants with cow's milk allergy. And we are still running a big study, the PRESTO study, where we look on microbiome effects, but also on immune development effects in these cow milk allergic infants. The data is in different target groups. We have safety data in healthy and in high risk and in allergic infants with extensively hydrolyzed formulas, but also amino acid formulas. And here's just a global overview of the studies and the objectives of these studies. And most of this has been published, so you can still look them up in PubMed. And also further speakers in this session will present a bit more data on the latest studies that we've done with this symbiotic concept. Just to highlight, now we have 3 big studies, randomized studies, to really demonstrate that symbiotics are actually able to target this dysbiosis that we see in some diseased infants, specifically also the allergic and cow's milk allergic infants. So intervention with symbiotics does increase, for example, the beneficial bifidobacteria. We see decreases of bacteria that are more common in adults. So the eubacteria and clostridial groups, they decrease if you use symbiotics. We also change the gut environment. So we see lower pH, shift in short-chain fatty acids, bringing the gut microbial physiology, I would say, much closer to healthy breastfed infants with using symbiotics in the diet of these infants. So in cow's milk allergic infants, in amino acid formulas even, we see this increased levels of bifidobacteria and reduced level of adult type of bacteria. And of course, this is important. These infants are diseased. They also have a specific challenge on the microbiome. So even if you give these infants a very special diet of amino acids, by adding symbiotics, we can really support composition, but also activity of the microbiome. And this is also the case in the non-IgA mediated allergies and in the IgE mediated allergies. So to conclude, I think we all are aware of the importance of the developing gut microbiome for the developing immune system, and that it's really important in early life to prevent also infections, so to get the wrong bacteria into the system. And human milk, of course, is a great aid there because it contains antimicrobials, antibodies, but also substrates for beneficial bacteria to guide this process of developing the right microbiome that is then able to also steer and develop the immune system in the right way. Symbiotics, combination of prebiotics and probiotics, also mimicking components in human milk, can target this gut microbiome dysbiosis that we see in many deceased infants. And we also now have 3 clinical studies showing that this specific symbiotic mixture is actually able to rebalance the gut microbiome in infants with cow's milk allergy and bringing it closer in composition, but also in activity, which might even be more important, to that of healthy breastfed infants. So this is where I would like to conclude. Thank you very much for your attention, your online attention, and we're happy to also have a panel discussion later on to answer any questions you may still have. So thank you very much again for your attention.
So thank you very much, Jan, for a very interesting presentation on this incredible world of the microbiota. And now we move to the presentation of Kirsten Bayer. Kirsten.
Yes, thank you for inviting me to give this presentation. My name is Kirsten Bayer. I'm head of the research clinic for pediatric allergy at the Charité University Hospital in Berlin, Germany. And I will talk to you today about the effect of symbiotics on tolerance development in infants with IgE-mediated cow's milk allergy. Before I give you my presentation, you will find here my disclosure. And this is a company-sponsored symposium, and I will receive a honoraria for this presentation.